give it energy. Ling and Mare are visiting the water park to try out a double-sided water slide, which looked like this. Being a risk taker, Ling opts for the steep side, essentially a free fall. Mel, on the other hand, preferred to avoid high speed. So she chose the gentle side. Both of the sides are equipped with sensors measuring each visitor's final speed, i.e., the speed at which they reach the water surface. Assuming no friction, how much greater will Link's final speed be compared to May's? Keep reading to find out or stay through today's challenge. We can compare the final speed with both girls using equations of motions. There are three one-dimensional equations describing a moving object in terms of time. They link the object's displacement in total and final velocities, acceleration, and total time in motion. It's straightforward in case of Link's free fall. However, to write down this equation for May, we need to know the slope of the slide. Luckily, there's another way. The only force driving the girl's motion is gravitational force. We call this force conservative, which means that the work this force does to move an object between 2 points doesn't depend on the path taken. In such a movement, many things can change: speed, position, and the height above the water surface. However, one important quantity is conserved: the energy. Energy is a physical quantity describing an object's ability to do work. It's expressed in joules. Okay. Energy is a physical quantity described. 1 joule is equal to energy transferred to an object or work performed on an object with a force of 1 Newton moves the object by 1 meter. Two types of energy dependent for moving object or kinetic energy, a type of energy related to motion, and potential energy, the energy that an object is due to its position in a gravitational field. During the movement, the sum of these two energies must remain constant, but the type of energy can change. Kinetic energy depends on the object mass, m, and the speed, v, and is expressed as E k equal to 1/2 mv. 2. Potential energy relates to the object mass, m, its position above the water surface, h, and the gravitational acceleration. Gravitational acceleration is the acceleration of a falling object in vacuum. It's approximately gram equal to 9.81 meters per second with a 2. Hour with 2 near the Earth's surface. And D, we express it as EP equal to mgh. Let's see what happens as the girls slide down the water side. They both start at h, in the beginning with speed of 0. So that means that in theory, the total energy of each girl is equal to potential energy. When they finish the slide, they reach the water surface. So this time the potential energies with respect to the surface equals 0. That means for each girl, the final kinetic energy is equal to intentional potential energy mgh equal to 1.5 mv power with 2, where m is the mass and v is the final speed of each girl. Notice that we don't need to know their mass, as this equation reduces to dh equal to 1.5 v power with 2. From here we get v equal to 2gh with a direct root. Oh my gosh, I just closed it. Fine. How did I reach? I think we reached here. And since both girls start at the same height, h, the final speeds must be equal. Notice that this would be true even for more complicated slides, because the final speed depends only on the difference between initial and final heights above the water surface. This principle will help you solve today's challenge. Today's challenge, Dara kicked up a 0.5 kilogram ball lying on the ground, is giving 15 J of kinetic energy. Assuming the gravitational acceleration, I said this, of 10 meter per second power with 2 and no air resistance, what was the ball kinetic energy when it reached 4 meters above the ground? Oh my